Now we're going to take a look at some of the things you can do with arrays. First of all, you can figure out the length of an array. All you do is type in the array name, which you've already declared, .length. It's not actually a method, although it looks like one. It's not a function. It's actually a built-in constant that's associated with the array. And when I say constant, it means as soon as you declare the array and the size, that becomes a constant value, the length of the array. You could access it any time. When you're traversing an array, that means you're starting from a certain index and you're going through to another specified index that you decide on. So for example, suppose I want to search an array A and I want to search it to find a certain target number. And remember, this is an array of doubles. I want to find a specific entry in that array. When I find it, I want to return the index of where that value is located. So I start out with my for loop. I have the initialization. J will be my index, my variable for using for the index. I'm starting with 0. I'm going to array length. Remember, I do a dot length. That'll give the length of the whole array. I don't go equal to array length because remember, it goes 0 to the length, 0 to 1 minus the length, rather than 1 to the length. So anyway, it starts at 0, goes up to just before you hit the length. Okay, and each time through the loop, I'm going to increment because I then want to look at the next index. So what I do is, first time through, I look at A0, that's the first entry. Is that equal to the target number? If so, return the index, return 0 in that case. If not, keep going down. Oh, I hit the bottom of the loop. Let's increment J. Now check the test condition again. Now J is 1. Is J less than the length of the array? Yes, it is. So I keep going until I find the target. If I go through all of the array, if I get up to array length, and I still have not found the target, I return -1. We talked about random numbers before in a previous lesson. Random numbers exhibit non-deterministic behavior, meaning it's an unpredictable sequence. Deterministic behavior is the same every time, and you can predict what it will do. But non-deterministic is a little bit harder to think about because it's unpredictable and you never know what to expect with it. A random number is something like that. A random number is something, every time you call random, you get a different number. You don't know which one you're going to get. You could get the same number repeated twice even. It's random. It doesn't matter. So suppose I want to fill up an array with random numbers. I set up my array with some specified size. Suppose I want 20 numbers. Size would be 20. So my array A will go starting from the first entry all the way up to the length of it. Each time I'm looking at a certain element location or index, I will put a random number in there. I'm putting in random numbers between 1 and 100. Okay, we're going to use this later in a program where we're pretending that we have some grades from students, grades that are 0 through 100%, and then we're going to look at some ways of analyzing that data. Okay, suppose I want to traverse the array and count elements that have certain attributes. Suppose I want to find out how many grades in my list of grades from my class are between, say, a 90 and a 100. I want to find out how many A's there are. I could traverse it this way, same thing. Start with the first entry in the array of grades. If that entry is greater than 90, greater than or equal to 90, and less than 100, actually I guess it should be 101 because I'm less than 100. Less than 101 would still include 100. If it is, increment the count and keep going till I'm done with looking through my whole list. That's kind of how we're going to do something kind of like a histogram when we look at the example next. Okay, there's something called an enhanced for loop. It's a more compact way of writing code for when you're traversing arrays. These two examples do the same thing. Here's what we were doing before. I start with index 0, I go up to the length, and I keep incrementing. I can put the value of the array index 0 into, I guess the array is called values. The integer primitive is just called value. So as I go through the array values, I assign them to value, the integer value, and I print them out. So I can traverse the array one by one and print out the value. Now this version does the same exact thing. It's a little more concise. I don't have to worry about array length. I don't have to worry about assigning. This will automatically, one by one, starting from the beginning of the array, going up into the last element, assign array 0 of the array value, entry 0 of array values to the integer value. Then the next time through the loop, it'll assign values index 1, and it'll put it into the integer value variable. And I print it out. Next time it takes values 2, element 2 in the values array, assigns it to my integer variable called value, prints it out. So these two do the same exact thing. So we'll take a quick look at some of the examples we talked about in this lesson. Some of them are actually in the previous lesson, the beginning of the arrays lectures. First of all, you have to import the arrays class. These are some examples that we're going to look at. So the class name of this file, again, it has to match the name of the class that I'm using. So in my main, in our previous lesson, we did some assignments to an array called counts. It had four elements. It initialized to 0 when we did this up here, when we declared it in an allocated space, and then I set some values. We'll print those out later. I can traverse the loop. I know that this array goes from 0 to 3, so as long as j is less than 4 and starting at 0, I'm going to print out every element and increment each time, go on to the next element. I'm going to use a for loop instead, do the same thing with a for loop, start at 0, go up until I is equal to 4 or less, as long as it's less than 4, continue, increment I, it should print out the same thing. When I use the print array function, this is one that's written in here. We've written that ourselves. So the array has 4 elements. I declared it right here and assigned it. And print array, let's see where that is. Print array, it'll start out with printing an open brace. It'll append the first element, and then it'll go through the rest of the array starting at 1, because I already printed out 0, starting at 1 until I get just below the array length, or 1 less than the array length, because if the length of 4, I'm going 0 to 3, increment I, print out the array element, a comma, and then the array element, keep going. When I'm done, close the brace. So that's my own version of print array. And let's see. So here we are. You can print out, remember, you can print out an array just like we did here, but we'll get unexpected results if we do it this way. This will print out the address of where the array is located, not the first element. If I want to print out all the elements in the array without using my own print array function, I could use the built-in from the arrays class. So it says use the arrays class method called toString, and it'll print out the array. It'll convert it to a string and print it out, enclosed by square brackets. Okay, suppose I want to copy an array. Here's my array. Here's the new array that's the same size. One by one, I copy element 0 into element 0 of A into element 0 of B. Keep going, element 1 of A into element 1 of B, and so on until I'm up to the array length. If I want to set C as a copy of A. The new array will have everything that's in A. That's pretty much going to do the same thing I did up here in the loop, except this is another built-in function that does it. Suppose I want to square every element in array A. I traverse through array A, take the element to the second power, and assign it to the same location. So element 0 of A will become element 0 of A squared. I assign it there. Okay, if I want to search for a certain element, I'm going to do a search. We talked about that a little bit in the lesson. I'm just basically going through the whole array until the element that I'm looking at, whether it's index 0, 1, 2, or whatever, is equal to the target. When it's equal, I drop out of the loop and return from the function or from the method, giving the index of where that target value is. If I can't find it, I get all the way through the loop. I went all the way to the end of A, didn't find it. I drop down here, return a -1. And that would indicate that I could not find it. And I think that I guess we total up. There's another method called sum, which basically totals up everything in the array. Element 0 plus element 1 plus element 2, and so on. So let's see what happens when we run this. Oops. Okay, so remember we assigned certain values to the array, and they're printed out here. We copied B. It's printed out here. This is the array. Let's see, what are we doing in main again? Let's double check. Okay, it's printing out each element in the array. I did it with a while loop. I did it with a for loop. I created another array, 1, 2, 3, 4. I printed it using my own function. Then I printed out as an object. The next one after that below here should be a strange looking address. Okay, so there's where I print out using my function. Here's where I just print out array A, system.out.println A. Remember, it gave the address of the first location rather than the value there, so I don't want to do that. But this is where I use the built-in function, where it does, let's see where that is. Here it is, the toString. It does, you can use system.out.println here. You couldn't use it here because this printed out the address of the array, but this one turns it to a string first, prints out all the elements. Okay, and then I was searching for a certain element. I couldn't find it. I totaled up the elements and I got 14. Okay, so that's about it for that one. Now this is a different example. It's basically showing how to set up a histogram of grade data. The first function in here, the first method, creates a array of random grades. So because I need something to work with. In real life, you'd have actual grades, but here I'm just creating something to work with. So I do this just like we did in the example previously. I go up from 0 to the array length, whatever size it is. Maybe I have 30 kids in my class or whatever. So I'm assigning random grades, random.nextInt. Okay, so it assigns this each element one by one some random grade. Okay, this will check. I'm looking for certain number of grades, or I'm looking to determine how many grades there are within a certain range. So maybe my range is 90 to 100. And in array A, I want to know how many grades I have that are A's. So between 90 and 100, and this will count them. It goes from the first element to the last element, incrementing each time. As long as A is between low and high, I count it. Otherwise I don't count it. Then I return count when I'm done. If I didn't find any, my count will remain 0, and I'll return the 0. We looked at print array already. Now, let's see what happens here. So I set up a random array with 8 values in it. I'm going to print out the random array. That's just going to show us what the random array is. Each time I run it, I should get a different value because they're random numbers. Now I'm going to set up a random array of 30 values, pretending there's 30 people in the class. Again, in real life, you'd have actual grades, but these are random, so we have something to work with. Okay, so I'm going to print them out, arrays to strings, so I can see what I'm working with. Then I set up something that only has 5 elements in it, the number of grades, because I want to know the number of A's, B's, C's, D's, E's, not E's, and F's. A's, B's, C's, D's, and F's. So A's are between 90, and I did go up to 101 because, remember, I'm comparing as something that's greater than or equal to 90, but less than the top value. I don't want to count 90 twice, so I don't want to do less than or equal here. I want to do greater than or equal here and less than here. So I want to include 101, so I can include 100 in my values. Okay, so I can run this. This will tell me in num grade sub 0, I'll have how many A's, num grade 1, I'll have how many B's, num grade 2, how many C's, and so on, and I can print them out. And then just in general, if I want to look at, suppose I have 100 grades. Okay, I have 100 grades. I want to see how many 92s, how many 93s, how many 73s, how many 74s, how many of each individual grade. So what I will do here is I go all the way through. Scores was actually passed in. This is supposed to be part of, well, where was scores? Up here. Okay, so we have the array of scores. Okay, so 30 of them. Okay, so I know that I'm going through all the scores array. Whatever that value is, that's what I'm going to use as my index, because if I have a grade of 90, I'll use counts and index 90, because I want to know how many of each specific number. So anyway, we can run this and see what happens. Let's see. So we can see here that we have, let's see what happened first. Here's my random array. Here are scores when I created 30 different scores randomly. Here are the numbers A's, B's, C's, D's, and F's. Now, this shows how many of each individual grade from a different random number that I generated. Well, actually, it's still from this 31 because I have 1, 1. I should have 195 and so on. Okay, there were two 297s, 100, 90, 9 98. Should have been 3 98s and 2 of these, whatever those were.